Let us solve October-November 24, paper 1, variant 1, AS Physics. Question number 1, what are SI base units of moment of force? Moment of force, torque, or turning effect is force multiplied by perpendicular distance. Force is kilogram meters per second square and distance is meters. If you simplify kilogram meter square S minus 2, the right option is D. Let us read question number 2. Which statement about the vector quantities is correct? Option A, the acceleration of free fall is vector because it has constant magnitude. It is vector, but the reason is not the constant magnitude. The reason is direction. Option B, the temperature is a vector. No, temperature is not a vector. Option C, the time is vector. No, time is not vector. Option C, weight is a vector quantity because it has direction. Yes, this is correct option. Question number 3. Density of material of rectangular block is determined by measuring the mass, linear dimensions of the block. The list shows the results obtained together with their uncertainties. The density is 2.5 grams per centimeter cube. What is uncertainty in this result? You know that the density is mass over volume. You also know the volume is length times width times height. So uncertainty in density will be uncertainty in mass, fractional uncertainty in mass, fractional uncertainty in length, fractional uncertainty in width, and fractional uncertainty in height. You all multiply by density's value. When the quantities are divided or multiplied, we add their fractional uncertainties. Now you put the values. I will take from here. As you can see, this, then we do divide like that, and like that. These are fractional uncertainties. So the density's uncertainty will be 0.1 over 25, 0.01 over 5, which is for length, 0.01 over 2, which is for width, 0.01 over 1, which is for height. You multiply all of them with the value of the density, which was 2.5. So you substitute here. So 2.5. When you calculate, it will be approximately 0.5. 0.05. Option C. Next question, question number 4. What is a reasonable estimate volume of one page of this examination paper? Please keep in your mind, these are A4 sheets. A4 sheets, their dimensions, you should know it is almost 20 centi. This is 30 centi. And thickness of a sheet, we take approximately 0.1 milli. So over here, the width is 200 milli, approximately. You need to memorize it. 300 milli. So the volume will be length multiplied by width multiplied by thickness. When you multiply them, 300, 200, 0.1 is 6,000. Option is C. After that, we proceed to question number 5. An object is projected from horizontal ground at a velocity of u and angle theta. It hits the ground at a time t after it is projected. Assume the air resistance is negligible. Which statement does not describe the motion? You need to choose the wrong statement in this case. The horizontal component of the velocity is constant and u cosine theta. Yes, horizontal is always constant as long as no air resistance, and it will be u cosine theta. This statement is correct. We need the incorrect. Horizontal distance traveled is t times u cosine theta. Let's check. Horizontal speed is u cosine theta, and you will multiply by t. Yes, this statement is also correct. The time taken for object to reach maximum height is t by 2. True. Time, if total time is t, so half time is to go up, half is to go down. So it means time to reach the maximum height is t by 2. This statement is also correct. The vertical component is constant? No. The vertical component is not constant. It changes due to gravity. It is u sine theta minus gt. So as time will pass, it will keep changing. So right option is D. Question number 6. A person traveling on a motorway a total distance of 200 kilometers travels first 90 kilometers at an average speed of 80. What is the average speed must be obtained from for the rest of the journey if the person is to reach the destination in 2 hours? No problem. We will use the first 90 kilometers and average speed to find the time. You can say T1, the time, if you use this triangle of average speed is distance traveled over time. So time 1 will be the distance over 80. So 90 over 80 is 1.125. So the remaining journey, its time will be, the total time was 2 hours. So it will be 2 minus 1.125. The time for the remaining journey is 0.875. So now the question is, what is the average speed for the rest of the journey? So rest of the journey, the time we know, the distance traveled will be 200 minus 90 divided by the time is 0.875. So the answer is 125.7, the option D. We find the time 1 for the first section of the journey, and then we subtract from the total time for the second section of journey, and we found the speed. Question number 7. I may erase the next part. The car has mass this, 1,200, momentum this, 18,000. Find the kinetic energy. We know the equation of kinetic energy in terms of momentum. It is p squared over 2m. You can just substitute 18,000 over 2 times 1,200. So once you simplify, it's almost 135,000. So right option will be C. Let's go to the question number 8. A ladder is positioned on icy, frictionless ground. You need to stop here and understand what does this have to do with the question. So if it is frictionless ground, so on ground there is no friction, so only force will be normal reaction at 90 degrees. So this means only force will be normal reaction. So this normal reaction has to be at 90 degree. Yes, 90, 90, not 90, not 90. So this option A and B, they are 90 degree on the ground because there is no friction. Now let's read the next part. This is lent against a rough wall. So wall has a friction. So wall will have two forces. So one will be if the ladder is placed like that. So imagine this one is ladder. So on the wall, there will be two forces. One will be the normal reaction, yes, and other will be the frictional force here. Normal reaction, frictional force. So it means the resultant will be somewhere here. So in which case the force by the wall is at an angle. The option is B. Okay, we proceed to the next question, question number 9. A toy parachute is dropped from a bridge and falls vertically through air. The graph shows the distance traveled by the parachute against the time. Which region on the graph shows when the parachute is at terminal velocity? Dear students, the meaning of terminal velocity means constant velocity. And constant velocity will be when the distance time graph is straight line with constant gradient. So straight line with the constant gradient, if you see, is this section. So option is B. We proceed to the question number 10. A lift consists of passenger car which is supported by cable that runs over the light frictionless pulley to a counterbalance. So here is the passenger car, here is the counterbalance. The counterbalance falls as passenger car rises. So this one falls and this one rises. Okay, some masses are given. Passenger car 520, counterbalance, and passenger's own mass. What is the magnitude of acceleration of the car when carrying just one passenger and pulley is free to rotate? You use the Newton's second law of motion that the MA is the total forward force minus total backward force. All right, so now you can see this goes up this way. So technically, the total forward force is because of the counterbalance. And counterbalance, forward force is its own weight. Okay? And the backward force is this one, the weight of man and the car. So the forward will be the counterbalance, which is 640 times 9.81. And the backward will be total passenger plus the car. If you add them, it is 600 kilogram. So 600 times 9.81. Okay, so let's solve this. So resultant force, the M, the total mass is, if you add them all, the total mass of the system is 520, 640, 80, which is 1240 kilograms. So MA is F net. Total mass is 1240 into acceleration. F net, the forward force was 640 times 9.81 minus the backward is 600 times 9.81. Now we simplify this equation. 640 times 9.81 minus 600 times 9.81, and then you divide by 1240, it is 0.316. So 0.316, it is 0.32. So the right answer is B. So that was a good question. Question number 10, we are done. We proceed to the question number 11. A stationary mass m is hit by the bat. The ball leaves the bat with the velocity v. The ball is in contact with the ball is in contact. Bat is in contact with the ball with 0. Delta t, average force. Force is actually change in velocity multiplied by mass over t. Change in momentum over t. So mass, change in velocity is v minus 0 because initially at rest over delta t, mv over delta t. The right answer is option B. Proceed to question number 12. A disk of mass m is moving across horizontal frictionless surface with a constant velocity. It collides with the stationary disk of mass 4m. So m, speed is u. This is stationary, means speed is 0. The diagram shows the view from the above of the motion of the two disks before and after the collision. What is initial velocity u of the disk with mass m? So we want this u. So you can use the principle of conservation of momentum, either this horizontal or the vertical. So if I use vertical here, okay, so this will not involve u because we want to find u. But if I use horizontal, it will involve. So certainly here also we need to take horizontal. We have to take both components of motion, horizontal separate and vertical separate, because there is another unknown v. So first I will take the vertical component. I'm going to highlight this with a yellow color, the horizontal, and with the green color, I will highlight vertical here and here. So if I use the vertical components first, before collision, the total vertical is 0. But after collision, the vertical, if you calculate, you multiply vertical components. I will resolute for you. Up is 4 multiplied by m multiplied by sine 45. Down will be 4m multiplied by v multiplied by also sine 45. So I will write the vertical up 4m sine 45, down opposite direction, so minus 4m v sine 45. You rearrange this equation, so 4mv sine 45 is 4m sine 45. So 4m sine 45. So v is 1. V is 1. Now we will use horizontal components. So horizontal here, before collision, horizontal will be m multiplied by u, and other is stationary, means 0. After collision, you have two horizontal components, one due to upper one, which is 4 into m into cosine 45. And this will also be 4m times v, and v we found as 1. We found 1 cosine 45. So they both are same. So 4m cosine 45, also 4m cosine 45. So m into u is 4 plus 4, 8m cosine 45. You can simplify m, so u is 8 cosine 45. Use the calculator, 8 cosine 45. 4 root 2, which is 5.66. The right option is D. So here you had to resolute horizontal separate and vertical separate. Proceed to question number 13. An object is dropped from rest on earth. The height is this. Write the data. Rest, initial velocity 0, height s. This is on earth. The same object is dropped from rest, also initial 0, from moon, but the height is twice. So if height is twice, it will be 4 meters. The acceleration of free fall on moon is approximately 16% of Earth. So if Earth, the acceleration of free fall is g, so on moon it will be 0.16 g. Assume there are no resistive forces. So what is the ratio of speed of object before hitting the surface of Earth to the speed before hitting the moon? You know v square is equals to u square plus 2as. In both cases, initial speed is 0. So v square is 2as. We will apply this square root. 2as square root is v. So you need speed on Earth. So up will be square root of 2g times 2 meter over. On moon, 2g will be 0.16 g into 4 meters. Okay. So I can make a whole square root. 2g into 2 to 0.16 g into 4. So over here, 2 and g you can simplify. So answer will be 2 over 0.16 times 4 square root. So let's calculate 2 over 0.16 times 4 square root 1.77. So which rounds to option A, which is 1.8. Question number 14. The graph shows how velocity v varies with the time for a bungee jumper. At which point the bungee jumper is momentarily at rest. So rest you want to find. So rest is when the speed is 0. So speed is 0 mean at point R. So at point R, you are at rest. So option might be C or might be D, my dear. Now they say 0 acceleration. So 0 acceleration for velocity time graph, the two ways are there. You can say gradient is 0. Gradient is 0. Or you can say maximum velocity. So when is the gradient 0? If you go, you draw a tangent, here gradient is 0. So gradient is 0. It means acceleration is 0. So option is Q, R, C. Question number 15. A solid sphere which is less dense than water is held completely immersed in the water for few meters below the surface. So if it is held completely in water, sorry, okay. So this is water, solid sphere is here. So as long as the particle is completely in water, so what happens? It's upthrust force, which is the rho GV. So it displaces the full volume, so rho GV will be constant upthrust. Okay. The density is uniform. The sphere is released. When you release the sphere, immediately release, it rises. So sphere starts to go up. So as long as in water, its upthrust force will be constant. Okay. Upthrust force is constant. Now, as you go up, your speed will increase. When speed will increase, the viscous drag force will also increase, which is opposing your motion. So when this opposes your motion, your resultant force will decrease. So the resultant force will decrease. The option is A. Next question, number 16. A uniform bar of weight 200 Newton, 4-meter length, freely hinged on wall at one end. Stop here. So the meaning of uniform mean its weight 200 is at midpoint. The weight is at midpoint. So let's go and label the weight, which is 200 newtons. Midpoint, so mean total length is 4, so this distance will be half of 4, 2 meters. Okay, let's keep reading. The bar is horizontal and in equilibrium. So equilibrium means the clockwise moment is equals to anti-clockwise. Cable is attached at a distance of 0.5 meters from the other end. Okay. So if the 0.5 meter is from other end, so it means this distance will be how much? 4 minus 0.5, which is 3.5 meters. Calculate the tension in the cable. No problem. So you identify the moments, my dear students. So over here, the 200 will tend to cause anticlockwise moments, while the T will tend to cause clockwise moment. So you do anticlockwise moment is equals to clockwise. So T will be T sine 35 multiplied by 3.5. While the 200 will have 2 meters. You solve them. 199.25. So the right option will be 200, which is C. Question number 17. The diagram shows a pair of equal forces. Which diagram shows the forces provide a couple? So couple mean equal opposite forces, different lines of action. Okay. They are equal but not opposite. They are equal, opposite, and different lines of action. B. C. They are equal and opposite, but line of action is same. When the line of action is same, they do not form a couple. D. They are not opposite. So only right option for the couple is B. Question number 18. A ball of mass m is thrown up a height h in air with the initial velocity v. Air resistance is negligible, so acceleration of free fall is g, which is constant. What is the total work done by gravitational force from P to Q? Work done by gravitational force is called mgh. mgh. From P to Q, there is no change in height, which is 0. So it means the work done is also 0. The option is A. Because there is no change in height from P to Q, the net work done is 0. Question number 19. Question 19, the spring of spring constant 30 Newton per meter. So K is 30 Newton per meter. Suspended vertically from its top. The spring obeys Hooke's law. Okay, so from top, suspended. Initially, it is not compressed, not stretched, but when you attach a mass of 0.5 kilogram to the bottom, the mass is released from rest. Yeah, you hold it, you release. So the mass will cause it to go down. You know, when it goes down, so the mass itself loses a GPE. That GPE will be mgh, and h will be the extension. Just keep in your mind. Now, my dear students, they say there is no friction. So in the motion that follows, what is the maximum extension? So we need this h, or extension. Here we'll use two concepts, my dear students. The first concept you use is this change in GPE is equals to elastic potential energy. Elastic potential energy. GPE is mgh. Elastic potential energy will be half kx squared. So mgh will be same as extension, which is half kx squared. You can divide by 1x on both sides, so x squared will become x. So this equation, now it will lead to a new equation, which is left side is mg, the right side is half kx. Half kx. So substitute the values. A mass is, what do we need? Extension x. So if you rearrange, it will be 2 mg divided by k is equals to extension. Substitute 2 mg extension. K is 30. So 2 mg divided by 30. 0.327. 0.327 will lead to the option D. The next question, number 20. A wire of original length L, cross-section area A. Tensile force F applied to the wire, which causes it to have extension X. Wire obeys Hooke's law. What is expression for Young's modulus? Easy. Young's modulus, we know that it is stress over strain. Stress, we know that it is force over area divided by strain. So it could be force over area, then strain, both are denominator. The right option, which matches F over A into strain, is B. Next question, 21. A wire is stretched gradually by increasing force. The force extension graph is here. Which statement must be correct? Okay. Point Q is elastic limit. Q. Q is not elastic. It may or may not be, but it is limit of proportionality. R is limit of proportionality. No, limit of proportionality is not R. It should be Q. Also wrong. Area under the graph from P to S is elastic potential energy stored in wire. It may or may not be right. Why? Because some work is done which is stored as internal energy as well, because it is deformed. So it is not necessary to be right. D. Area under the graph is the work done in stretching. Yes. So this work done could be either the internal energy, or this work done could be as the amount of work done to which is stored as elastic potential energy. Question number 22. A spring has unstretched length 0.3. You can say original length. Spring constant is 400 K. The object is suspended from the spring and the spring is deformed within the limit of proportionality. So it means you are obeying Hooke's law. So nu is this one. So it is nu length. So it means extension is 0.5 minus 0.3, which is 0.2. So find the elastic potential energy. Easy. So elastic potential energy is half kx squared. Half kx squared. So if you simplify, and the answer comes to be 8, 8 joules. Question number 23. A wire consists of 3-meter length of x and 1 meter of y. So you can see the x is 3 meters and y is 1 meter. Cross-section area is uniform. A load is hung so that the x extends by 1.5 milli. Okay, so 3 meter length extension is 1.5 milli and y extends 1.0. So this 1 meter length, it extends by 1 milli. Okay. Now the question says the same load is hung from the second wire with the same cross-section area consisting 1 meter of x, 3 meter of y. Okay, so the new length is 1 meter for x and 3 meters for y. So this wire was x and this wire is y. So they say, what is the total extension? Dear students, if you write the Young's modulus formula, E is equals to FL over AX. X is equals to FL over AE. Force is same. Cross-section area is same. Young's modulus is same. So it means extension is directly proportional to length of the wire. Apply this concept here and here. So the first wire X, the length was 3, extension was 1.5. The length is now, 1. So extension is how much? Crisscross. So this extension is 0.5 millimeter for X. New extension for Y will be 1 was 1 milli. So 3 is how much? So this 3 will cause the extension of 3 milli. So my dear students, what is the total extension now? So total extension in new case, you will add them. So if you add 3 plus 0.5, 3.5 milli, the answer is B. Question number 24. The graph shows the variation and the displacement and distance of progressive waves at one instant. The period is 91 milliseconds. So period means uppercase T, 91 milli means 10 power minus 3 seconds. What can be determined about the waves? Velocity, let's find the velocity first. And we can also find the frequency. So if you find the velocity, so we need to know the wavelength. So wavelength is when the full wave is completed till here. So its wavelength is 4 centi. 4 centi mean 10 power minus 2 meters. So if you find the speed is the lambda over t, which is 4 into 10 power minus 2 over 91 into 10 power minus 3, 0.4396, which is approximately 0.44. Okay, so its speed is 0.44, and now frequency. Frequency is 1 over period. 1 over 91 milli. It's 10.99, so frequency is 11. So speed 0.44, frequency 11. Answer A. Question number 25. Which group of electromagnetic radiation arrange in order of shortest wavelength to longest wavelength? I always say a sentence, Real Madrid is very ugly except goalkeeper. Real Madrid is very ugly except goalkeeper, and then you make a spectrum like that. So now, my dear students, you should know if you go down, the wavelength is shortest. So you want shortest to longest. So it means you want to go this way. So option A is a radio. No, radio is the longest wave. Visible, micro, infrared. Let's check. Visible, micro. No, wrong. Option B. Option C says visible ultra X-rays. Visible ultra X-rays. This is also decreasing wavelength. No. D. X-rays, infrared, microwaves. X-rays, infrared, microwaves. Yes. So wavelength is increasing. So shortest is X-rays from here, then infrared, then microwave. Option D is correct. Question number 26. A wave has a frequency of 5 gigahertz. What is the period? No problem. Giga. Giga is 10 power 9 hertz. So period is 1 over frequency. 1 over 5 into 10 power 9. It is 2 into 10 power minus 10. Okay, so let's check option A, the pico. To change into pico, you divide by the value of pico, which is 10 power minus. You multiply by the value. Sorry, yeah, you want to convert to pico, so divide by 10 power minus 12. 200 pico. Option A is correct answer. Because 200 pico is also 2 into 10 power minus 10. So answer is A. We proceed to the next question. Question number 27. 3 statements about the progressive waves are listed. Okay, 1, the waves have same frequency. Waves have same amplitude. Waves are emitted with a constant phase difference. Which statements must be correct for coherent? Coherent means they must have constant phase difference as well as same frequency or wavelength. So option is 1 is correct and 3 is correct. Amplitude is not a condition for coherency. So option C. We did the next question. Question number 28. Waves P and Q have the same amplitude. The waves meet in phase at point X and interfere to give the resultant intensity X. Okay. So first of all, read this. They have same amplitude. Okay. And the resultant intensity is I. Stop here and let's talk about that. So maximum when they meet in phase, So their maximum amplitudes are added up. So amplitude of 1 and amplitude of 2, so 2A. You also know the intensity is proportional to square of amplitude. Okay. Now case 2. Case 2, I will highlight with a different color for you. The amplitude of the wave P is doubled. Okay. So now what happens? The one wave is 2A, the other wave is A. So resultant will be 3A. So what will be the new intensity? So new intensity, you will say, for example, X is proportional to 3A squared. So you cross multiply, X will be I times 3A whole square divided by 2A whole square. So I 9A square over 4A square. A square cancelled, I times 2.25, which is approximately option C. So one of the amplitude was doubled, so resultant is 3A. So 3A I compared with 2A with a squared relationship. The right option is C. We proceed to the question number 29. Which waves can be polarized and which cannot be? Radio waves, polarized, yes, because they are transverse. Sound cannot be, yes, because they are longitudinal. Longitudinal waves cannot be polarized. So they say which statement is correct? I already told you sound cannot be polarized because they are longitudinal. So radio waves generally give higher frequency than sound, not a reason. Radio waves are transverse, yes. Sound waves are longitudinal, yes. That's the reason. Proceed to question number 30. Question 30 says the light of wavelength lambda is incident normally on a diffraction grating with a number of lines n in width w. Okay, so over here, diffraction grating, this is second order. So n is 2, lowercase. What is the capital N? No problem, we can write. Diffraction grating formula is n lambda is d sine theta. So n lambda, n is 2, lowercase, d. D is actually number of lines per unit length. So D is capital N over W. Then, no, D is the width. So for each slit. So D will be W over N. So W over N sine theta. So capital N, you rearrange, it will be W sine theta divided by 2 lambda. W sine theta divided by 2 lambda. The answer is C. After that, the next question is question number 31. The Kirchhoff's second law is consequence of which? Please keep in your mind, the second law is conservation of energy. And the first law is conservation of charge. So which principle? The charge flowing is conserved. Charge is conserved, but for first law, not for the second law. Energy in an electric circuit is conserved. Yes, that's the Kirchhoff's second law. Kirchhoff's second law says that in a closed loop of a circuit, the sum of all EMFs is equal to sum of all PD. So EMF and PD, they both are energy per unit charge. So that's why energy has to be conserved. Question number 32. The diagram shows a circuit with a LDR. Emitter reads 0. So if emitter reads 0, this is called null condition. This is called null condition. So null condition or potentiometer means the ratios of the resistances is same. So what is the resistance of LDR? So if you say this R, so you will say R divided by 6 is same as 30 divided by 10. All are in kilos, so R will also be in kilo ohms. 18 kilo ohms. It's a very easy question. So answer is B. Let's read the next question. Question 33. A torch uses 3 lamps in parallel. Make 3 lamps. 1, 2, 3. To internal resistance, the terminal voltage, which is E minus IR, it will be less because some PD is lost in the internal resistance. So effect on E, the EMF will be same, but terminal will decrease. Option C. Option C, my dear students. We proceed to the question number 36. In the circuits shown, the batteries are identical and all have negligible internal resistance. All of the resistors have same resistance. The diodes have zero resistance when conducting, infinite when not. Which circuit is the current greatest? Easy. So current will be greatest if both diodes are forward biased. Okay, so both diodes forward biased. Let's check each. Current goes here. Can pass? Yes. Can pass? Yes. Both are forward. B. Pass? Pass. Okay. Now A and B, A, they are in parallel. In parallel, the combined resistance is less, so current will be more. While B, they are in series, the combined resistance is more, current will be less, so not B. C is wrong because diode is not conducting. D is also wrong. This diode is not conducting. So both diodes are conducting and they are in parallel. The right option for maximum current will be A. We move to question number 37. A potentiometer circuit is used to determine the EMF of a cell. This EMF you want to find. The circuit includes a second cell of 1.5 volt. This is 1.5 volt. Internal resistance is 0.5. It is connected to the uniform resistance wire XY. And the resistance wire, the length is 0.96, which is also 0.5 ohm. So, dear students, if you only talk about this part of the circuit, which I'm going to highlight, this loop. In this part of circuit, this total resistance is how much? 0.5 ohms. And this is also 0.5 ohms. So for wire XY, the voltage will be 1.5 divided by 2, which is 0.75. Why 0.75? Because half and half, both resistances are same. So voltage will be shared. Okay, now if you again use this number, this one, the 0.96 meter, the voltage is 0.75 volt. So for 0.64 will be how much? Potentiometer mean the ratios of EMFs is same as voltages, resistances. So you will say E ratio 0.7 ratios of the voltages is same as the length 0.64 ratio 0.96. So ratios of the voltages has to be same as ratios of the EMFs, the resistances. So if you simplify, the answer comes to be 0.5 volt. Option A. We move to the question number 38. Which particle is not a fundamental particle? Charm quark, it is fundamental. Electron, it's a lepton, which is also fundamental. Neutrino, it is a lepton, which is also fundamental. Neutron is not fundamental. Why? Because it is made up of 1 up and 2 down quarks. So it has internal structure. So neutron is not fundamental. Option is D. Question number 39. Fluorine isotope undergoes beta plus decay to form a stable isotope. Let's make it fluorine. 9 with 18 gives you beta plus. Beta plus is 0 and 1. Stable isotope, for example, it is X. Of course, there will be a neutrino. I don't want to talk about antineutrino, neutrino. So X, if you balance, up will be 18, down will be 8. So how many neutrons are there in the stable isotope? So in this isotope, how many neutrons are there? So 18 minus 8, which is 10. Option D, 10 neutrons. Last question, the question number 40, and we are done. Which statement is correct? Okay, a baryon is a hadron, yes. Which consists 2 quarks? No. The baryons have 3 quarks, not 2. Meson is a hadron, yes. Consists of 3 quarks? No, opposite. This should have a quark and antiquark. Only 2. Wrong answer. An electron is fundamental, yes. And it is a lepton, yes. Option C. A neutrino is fundamental, yes. And hadron, no, it is not hadron, it is lepton. So right option is C. So thank you. And you can suggest me what next paper should I solve for you. Take care. Bye bye.